Hello and welcome back. In this session, we are going to learn how to check the longest valid parenthesis. And here is the problem statement. Uh, and it reads as given a string containing only the characters open parenthesis and close parenthesis. Find the length of the longest valid parenthesis of a string. And then we have here one sample input. We have close parentheses, a couple of pair of open and close parentheses, and then finally we have one last close parenthesis. And in this one, the first one open the close parenthesis, the first one I think I said is open parenthesis before, so this should be yeah, so this is invalid because it doesn't have a corresponding open parenthesis. And then we have this pair open close, that's valid. And then finally we have closing parenthesis, and it doesn't have a corresponding opening parenthesis, so it's not valid. So the longest, the count is obviously 4 here, so that's what we are going to validate and then produce the count. Let's get started with Java implementation. And we're going to we're going to do a typical implementation where we'll iterate through this is string, once from left, once from right, and then we didn't have to go anything beyond that. That means in the worst case, the most number of iteration that we'll be conducting will be order of n. So the time complexity is order of n, and we are not doing the additional storage, so it's always a constant storage. So the space complexity is order of 1. Okay, let's get started with the Java implementation. I am going to name my file as longest valid parent .java. Okay, all right. Longest valid parenthesis, and I start with my main method. Main parts, and we'll come back to this one. Let's get a signature of the method that we're going to implement first. Private static int. Yeah, we have been we already talked about, whether it should be private, public, static. It needs to be static because we're going to call from the main method, which is also static. But private, it doesn't matter for us here whether it's private or public. It can be public as well, so we're not focusing on those visibility things. We're primarily focusing on the algorithm. So it takes a string, which is a combination of brackets, obviously, and I'm calling that my expression, which is expression basically. Okay, we'll come back to this one. Let's go back to our main first and try to just complete it. I mean, we have at least a signature. Actually, here it has to return. Well, for now we are doing null. We will come back and we'll come back and fill it. All right, so our given expression, we remember it. It's one closing parenthesis, and then we have a couple of opening, closing, the well-formed one, and now we have one extra, right? That's our given expression. We can obviously have different kind of expression and test, but that one I will leave it to you. My result equal to longest. That's the method that we are going to implement. We have a signature, so I know what to pass. Valid parent, and I'm going to pass given expression, given expr. Okay, and that's what I'm going to print. Okay, is it because it returns the count? System out print my result Okay, so I'm going to write that. Now I need to complete this method over here. Let's do that. And to get it started with, the logic is, you know, we go first we go from left to right, and we do scanning, we do comparison, and accordingly we increase the counter. Okay, second time we go from right to left, we do scanning, we check the characters, so closing, opening, closing parenthesis, and then we increase the counter accordingly for the max length. That's it. It looks very simple actually. Yeah. You can also do the little exercise in the paper if you have time, or on the board actually. That's even very interesting. But here first we're going to do the implementation, because that's I think that's what we want to see. Okay, int, we'll have two variables. Left we start with 0, and right also the count, right? Okay, this is a count, so that's also 0. Int max length is equal to 0. Okay, and then eventually what happens is we return that max length. Okay, we return that max length, but we need to do something before we actually can return that. Okay, right. Okay, so we have we'll have two for loops, one for scanning from left to right, another for from right to left. Okay, for int I is equal to 0, I is less than my expression length. Okay, I plus plus. Okay, this looks very familiar. We have been using this kind of for loop many times, so it doesn't need explanation. My expression dot, okay, caret I char at, and okay, it gives the character at I position. If that is initially is 0, next time it is 1. Okay, we're checking something. What are we checking? We're checking the opening parenthesis. Okay, if it is opening parenthesis, what are we doing? We are doing increment. We need to just increment left is equal to left plus 1. Okay, otherwise we are going to increase the right. It's right parenthesis, right? Because we have only either left parenthesis or we have right parenthesis. Okay, that's it. All right, that's it. And then at some point what happens is this can come equal. Okay, from left to right, so this can be equal. Left is equal to right. If that is the case, then and we do this thing. Max length is equal to max length up to this point. Initially obviously 0, and 2 multiplied by, we're doing the right. Okay, why we're doing multiply by 2? Because it has to be well formed, it has to be a couple, right? That's the thing. All right, so, and we're doing right because if you're saying right, probably we wish left as well. Okay, so otherwise it's not a match. And then obviously we are in the left is equal to right, so they have equal number of count. All right, so otherwise we'll check this one. Since we have given left to right, we're checking this one. Okay, this is important to remember, right? Greater than or equal to left. Yeah, if that is the case, it is already a mismatch. Okay, so we're resetting because there's a mismatch. You have to see another matching pattern there, right? Okay, so and that's for if, and that's for that for, where is it? Yeah. Okay, now so this is left to right. The next one we are going to do is, obviously it's the same method, but it will be a different for loop because we will have right to left scanning. Okay, now for that also we need to initialize. Okay, 0. Okay, let's also save at the same time. Okay, we're initializing, or you could say you're resetting. Okay, okay, now I starts from my expression dot length, that's a string as well, bracket minus 1. Okay, that means I'm going to the rightmost element, and then I greater than or equal to 0. Okay, I can go up to 0, and every iteration, since I start from the right, I come toward left, that's why I need to decrease my I. Okay, and other stuffs are pretty similar. You'll see the similarity here. Here also we check my expression dot char at I, if that is equal to left parenthesis, then we are going to increase the left count. Left is equal to 1. Otherwise, we're going to increase the right count. Okay, and then like before, we have to check if left is equal to right, and in this case calculate it. Max length is equal to math dot max. This method is available in the math class. Max length length, and this time we multiply with the left, 2 times left, because we are scanning from the right to left, right? Okay, otherwise we check, since we are scanning from the right to left, we are checking whether left is greater than or equal to right. Okay, and if that is the case, then it is a mismatch, so we just reset that. Okay, and then it will iterate again for another substructure inside. We have that return here. Yeah, so this pretty much completes only 45 lines of code. Fairly interesting implementation. We're done actually. So this should do the job if we didn't make any syntactical error, but I think we have some syntactical error. Let's see that, and it will tell us how many we made. Okay, this car at, okay, there is one extra T, that is line number 13. Okay, line number 13, there is one extra T there. Okay, alrighty, I will go back, save and exit, compile. Okay, let me do that one more time. Okay, that's our class. If it is right, it should produce 4. Okay, it produced 4 because do cat on this one. Sorry, that one's sour. It produced 4 because we have, let's see over here, you see in the highlight, that's the valid one, the valid combination, right? Well form. 1, 2, 3, 4, right? That's why we will answer 4. So this completes the Java implementation. In the next video, we will be seeing Python implementation.